Together, Vestas and Stena Recycling are scaling a new process to create a circular economy for wind turbine blades. After cutting and preparation, the journey has reached a major milestone. Here, at Stena Recycling's Testbed in Halmstad, blade parts are prepared for large-scale separation, bridging lab-scale results to industrial-scale solutions.
So in Vestas, we have a strategic target on zero waste wind turbines in 2040. While most of the turbine is made of steel that's already recyclable, then the remaining part is primarily composites. We need to find a solution to be able to recycle composites.
To recycle a complex material as a wind turbine blade that is designed to last for decades in very, very tough conditions is very hard without destroying the properties of the materials. So that will require unique recycling processes. The milestone where we are going from lab scale to testbed really means that we have full control over the ingoing processes and start focusing on the recycling system instead.
Together with Stena Recycling, we've taken this technology out of the lab, scaled it up close to the tons scale.
The testbed is very proof that the process can work beyond the lab scale, safely, consistently, and at volumes that the industry can actually use.
In the lab, you can test chemistry in kilograms. In the testbed, you can prove quality and purity level, as well as safety, repeatability, and volumes that partners can validate.
We receive the blade in the big size and then we cut them in the right dimensions that we can put in the reactors in the testbed, and then we add the chemicals. And the testbed is unique because it provides us a method to separate different materials in the blade, like glass fiber, aluminium, epoxy powder, and PET foam, in a way that we can recycle them individually.
You can say that it is a representation of a full-scale recycling plant, but in a very small scale.
So what we are seeing here is the first step of the recycling process, namely the separation of the materials. So with this process, we can separate the material fractions into all the components. This separation step is essential to get the full value out of the materials and to optimize the further recycling process specifically to each material type.
A wind turbine blade is a multi-layered composite. Circularity requires separating each layer into its own material stream.
Success from the testbed would definitely be to find solutions for all of the materials that are optimized, where we have economically viable process here at Stena Recycling, and that there will be a mature market that can offtake this material when we have recycled it.
Here, industrial recycling expertise and innovation come together to turn laboratory breakthroughs into industrial solutions the market can use today.
Working together with Stena Recycling have been really rewarding. We come very different backgrounds and very different expertise, and this collaboration is crucial in making the scaling possible.
There are many different markets that this material could go into, and we are very confident that the material is capable of going into new high-performance products.
But the focus shifts now to supply enough recycled material to our downstream partners so they can develop their processes and we can together optimize the complete value chain.
The next step is what happens after separation, when recycled material must meet real-world quality standards, and how recycled blade material can be repurposed for new applications.